Looking for the best GPU for AI without wasting time and money? Here are the top 5 picks, ranked from solid to legendary, with real-world pros, gotchas, and the kind of nuance you only notice once you've trained models for days on end. Alright, quick intro. In this video, you'll see how each GPU handles large batch sizes, VRAM-hungry fine-tunes, mixed precision stability, and multi-GPU scaling, so you can match your workload, LLMs, diffusion, vision transformers, or video to the right card and budget. Stick around because the top 2 flip the script on what workstation versus data center really means for AI throughput and reliability. 5. PNY NVIDIA Quadro RTX A5000. So, the RTX A5000 is one of those cards that, at first glance, feels like a quiet professional. 24 gigabytes of ECC GDDR6, 8,192 CUDA cores, and Ampere tensor cores that will chew through FP16, BF16 with confidence, you know. In workstation builds, it slots in cleanly with 230W max power and PCIe 4.0, which makes it easy to cool and easy to trust for long training runs on small to mid models. If your bread and butter is stable fine-tunes of 7B class LLMs or medium diffusion workloads, it's a dependable daily driver. Features-wise, you get 256 3rd-gen tensor cores and 64 RT cores. Nice if you straddle AI and rendering. And ECC memory helps prevent silent corruption during long jobs, which is underrated when you're running overnight on a shared workstation. NVLink support on the A5000 is a genuine boost for paired setups where you need VRAM pooling or faster inter-GPU transfers in data pipelines. It's the It Just Works option for mixed DCC AI teams. But well, here's the thing. For pure AI training, a memory bandwidth and raw tensor throughput aren't in the same league as the higher-end Pro or data center SKUs, and 24 gigabytes VRAM becomes a ceiling fast for 13B plus models unless you aggressively shard or offload. You'll feel it when you push context windows or image video batches up. The system starts juggling I/O and the iteration time spikes. If you're stepping into heavier transformers or multimodal stacks, you'll bump into that limit sooner than you think. 4. NVIDIA GeForce RTX 4090 Founders Edition. The 4090 FE is the wild card, a consumer flagship that frankly punches way above its weight in AI for the price. Thanks to 16,384 CUDA cores, 4th-gen tensor cores, and high clocks on Ada Lovelace, you feel the speed the first time you hit mixed precision with big batches, iteration times drop, and suddenly your experimentation loop feels, alive again. With 24 gigabytes VRAM and monstrous core counts, it's a prototyping dream. For diffusion, image video models, and most 7B to 13B LLM fine-tunes, it's a rocket, especially if you're smart about gradient checkpointing and memory-efficient attention. The boost clock around 2.52 GHz gives it realistic sustained throughput that makes older Ampere Pro cards look a bit sleepy in head-to-heads on consumer frameworks. If you're a solo creator or small lab, the perf per dollar is honestly ridiculous. Now, the caveats: no ECC on VRAM, which does matter for long, critical training where data integrity is non-negotiable. And while 24 gigabytes is usable, larger LLMs still demand sharding or CPU NVMe offload that complicates pipelines. Also, Founders Edition thermals are good, but this is a 450W class card in practice for heavy runs, so you need airflow, a capable PSU, and an eye on that 12V HKWR connector. It's powerful, but not exactly gentle. Another wrinkle: driver and framework optimizations for Ada are excellent for consumer workflows, but if you require vGPU, SRIOV, or enterprise virtualization stacks, the 4090 won't replace a pro data center board. 3. PNY NVIDIA RTX A6000. Moving up, the RTX A6000 is where professional reliability meets real AI headroom. 48GB GDDR6 with ECC, 10,752 CUDA cores, 336 tensor cores, 384-bit interface, and 768 gigabytes per second bandwidth on Ampere. That doubled VRAM versus the 4090 changes everything for 13B plus models, larger context windows, and video pipelines with higher resolution or longer sequences. The difference you feel is not just speed, it's freedom from contortions. On long trainings, ECC is the quiet hero, and at 300W max power, the A6000 stabilizes nicely under sustained load in workstations without screaming fans. PCIe 4.0 keeps host transfer snappy for data-heavy steps, while NVENC generations are solid for video-heavy AI pipelines where encoding and decoding can bottleneck throughput. It's a serious card for serious, repeatable work. The 48GB capacity means larger batches and fewer offload hacks, which reduces complexity and improves iteration consistency. You can hold bigger models fully in VRAM during fine-tune passes, and that translates into fewer weird edge case OOMs mid-epic. For multimodal experiments that blend vision and language, the extra headroom feels luxurious. Sure, on raw step time the 4090 sometimes edges it in small to mid models due to higher clocks and ADAs per SM improvements, but once you scale model size, the A6000's memory footprint becomes the deciding factor. And when dealing with production workloads that need consistency and auditability, ECC tips the scales. In short, if your workflow has matured beyond make it run and into make it reliable, the A6000 is a sweet spot that keeps single GPU workflows sane and performant without drifting into full data center territory. 2. PNY NVIDIA RTX 6000 ADA. Now we're talking modern pro muscle. The RTX 6000 ADA brings ADA architecture with 48GB GDDR6 ECC, improved tensor and RT generations, and notably higher efficiency and clock behavior than Ampere Pro boards. In real workloads, that means faster epochs at similar memory footprints, smoother, mixed precision, and better thermals for 24/7 duty. It feels like the A6000, but sharper, quicker, and more at ease under pressure. ADA's architectural gains plus high clocks make this a monster for transformer training, diffusion XL-class workloads, and video generation pipelines where both compute and VRAM matter. When you push long context windows or work with multi-GPU data parallelism, the RTX 6000 ADA maintains consistency without the hiccups seen on more consumer-tilted cards in heavy enterprise stacks. It's the Pro card that truly earns the AI workstation label. The 48GB ECC memory keeps your pipeline simpler than anything with 24GB, and you feel that in fewer gradient checkpoint contortions, larger batch sizes, and more stable throughput. The card is also friendlier to power and cooling than you'd expect given the performance, which helps when you're building dense workstation rigs with predictable acoustics. Compared to the A6000, you get ADA's generation uplift and better efficiency. Compared to the 4090, you get ECC and Pro driver support that enterprises care about. If you're scaling a team's workstation fleet for fine-tunes and heavy inference, this is the balanced, future-facing choice. NVIDIA Tesla A100. At number 1, the A100 is, well, the gold standard for serious AI training. Ampere data center silicon with gigantic tensor performance, high memory bandwidth, and SKUs that go up to massive HBM capacity with ECC. Built for cluster scale work and uptime, even the 40GB class delivers a different class of sustained throughput under FP16, BF16 with sparsity. And when you step into larger HBM variants, your pipeline simplifies and your scaling behavior just behaves. This is the card you pick when your training runs are measured in days, when you care about determinism, and when your bottlenecks are orchestration and I/O rather than raw compute. Inference on large models becomes predictable, and mixed precision stability is outstanding. It's not about pretty benchmarks. It's about finishing Epoch 17 the same way you started Epoch 1. With data center drivers, MIG, and enterprise support, The A100 fits neatly into shared infrastructure without stepping on other workloads, and that's huge for teams who can't dedicate entire nodes to single experiments. The software ecosystem around it has matured to the point where deployments are boring, and boring is beautiful in production AI. Does it cost a lot and require appropriate servers? Yes, and that's the point. If you're at the scale where downtime is expensive and throughput is king, the A100 pays for itself by eliminating the friction that smaller or consumer hardware introduces. It's the difference between grinding and gliding. Final thought. So, which one should you get? If you're a creator or indie researcher who needs rapid iteration, the 4090 is the best price-performance accelerator right now. Just accept the 24GB ceiling and lack of ECC. If you need reliable pro workflows with big VRAM in a workstation, the A6000 is a proven anchor, and the RTX 6080A is the sharper, faster evolution. If you're building production AI at scale, the A100 still wears the crown for stability, uptime, and end-to-end throughput. Quick recap with vibes. The A5000 is steady, the 4090 is fast and feisty, the A6000 is mature and capable, the RTX 6080A is refined power, and the A100 is the North Star for training that just needs to finish. No drama, no surprises. Pick the one that fits your model size, tolerance for complexity, and how much your time is worth.